Okay, good day. This is Coshocton High School Mathematics Department Honors Algebra 2, Blizzard Bag number 2. I am Mr. McCully. Let's get right to it. Hopefully yesterday's was not too bad. Today we're going to review transformations of functions, and so we're going to quickly talk about some simple parent functions. We're going to describe some transformation of parent functions, and then we're going to write some equations from graphs of rigid transformations. So just a quick review of the parent functions. It's just f of x equals c. The constant function is just a horizontal line. F of x equals to x is just a linear equation that has a slope of 1 and a y-intercept of 0. F of x equals x squared. That is your simple parabola. F of x equals absolute value x. That is that v-shaped, and then you have the square root function. And remember, you can't take the square root of a negative number and have a real result. F of x equals x to the third. Remember that graph looks a little bit like this, where he comes up and then goes like that. And then f of x equals 1 over x, and if you remember 1 over x, it looked like this, where we have that division by 0, so we have a horizontal asymptote. So just a quick review. And then when we talk about the transformations, and again, these are in your notes somewhere, so you could look them up, or when you do the practice work, you could pause on this page. F of x plus c is going to be a vertical translation c units up, and then f of the quantity x plus c is a horizontal translation c units to the left. And remember, whenever you're doing something to the variable, it's going to seem opposite of what your intuition might automatically give. If you take f of negative x, that's going to be a reflection about the y-axis, and then negative f of x, that's a reflection about the x-axis. These are all the rigid transformations, meaning that they don't change the shape. And then if you multiply x by a scalar before you do the function, that is going to be a horizontal stretch by a factor of 1 over c, so it's going to shrink it horizontally. It'll get a little smaller. And then when you multiply by a constant, that'll be a vertical stretch by a factor of c. These are non-rigid transformations because they do change the shape. All right, let's take a look at an example. And our first example is, here we're given the function f of x equals negative square root of the quantity x plus 3 minus 2. And they want us to name the parent function. Well, for my part A, I am going to say that my parent function is just going to be y equals square root of x. And then we need to describe the transformations. Now, if you remember, the way that I describe the transformations is I'm going to plug a number in, and then I'm going to see what happens to that number as we evaluate, and then we will write the transformations compared to this y equals square root of x. So let's say, just as a for instance, I'm going to let x equal 5. So if I plug 5 in for x, the first thing that's going to happen is I'm going to add 3. So when I add 3 to the variable, if we look back here, adding to the variable, that's a translation c units left. So this thing is going to first translate 3 units left. And then after I've calculated that, I get 8. The square root of 8 isn't going to come out nice, but that's okay. So that's the function. After I've done the function, it's going to make it negative. So if I make the function negative, making the function negative right here, that's a reflection about the x-axis. So I'm going to reflect about the x-axis. And then the last thing is this subtraction of 2. So again, I've done the function, so I'm subtracting 2 from the function, which is this one right here. If you add, it's a translation up. So if we're going to subtract, that's going to be a translate 2 units down. Now, if you're unsure, you can always go to Desmos, and you can type in both the parent function and the original function. So if I go y equals, and then we put a root in there, x, and then we go y equals negative root x, and then it was plus 3 and then minus 2. And so clearly we see that we have a translation, 1, 2, 3 units left, 1, 2 units down, and it's reflected about the x-axis. So I feel very confident of my solution right here. Okay, next example. It says the graph below was created using only rigid transformations, so no stretches. We want to name the parent function, and then we want to describe the transformations from the parent function to the graph. And then we want to write equation for the transform graph. So that's what we're going to finish it up with. So A, well, this shape here is my y equals x to the third function. And so if we go back to Desmos here real quick, and we clear out all this stuff, and I just go y equals x raised to the third, I get a graph that looks similar to what I have there. Now, I do notice that this graph is always increasing, but the graph we have here is always decreasing. So we have to come up with some transformations to get that. All right, so part B, let's describe our transformations. So it looks like I have another reflection in the x-axis. Now, something special about the x to the third function is it's symmetric about the origin. So you could also say that it is a reflection in the y-axis, but that's neither here nor there. It looks like I'm translating, and again, I'm just going to look at this 0, 0 point because it's an easy point to translate. And it looks like it has been translated to this point right here, which would be 1, 2 units to the right and 1, 2, 3 units up. So we're going to say translate 2 units right, and we're going to also translate 3 units up. All right, so part C says that we want to write an equation for the transform graph. So our transform graph, we're going to call it g of x. All right, we want to reflect we've got this x to the third, and we want to reflect in the x-axis. So I'm going to put a negative out in front of that to the third. 2 units to the right. Well, if 2 units to the left was a plus, then if I want to go right, I'm going to subtract 2 units. And if I want to go 3 units up, I need to add on the outside to get that. Now, if you're unsure with your solution here, what we'll do is we'll just go back to Desmos, and we'll leave that x to the third, and then we'll go g of x, and we'll just type in what we had. We'll go equals negative x, and then it was minus 2, parenthesis, raised to the third, and then we go plus 3, and clearly take that 0, 0 point and move it 1, 2 units to the right, and 1, 2, 3 units up. I feel very confident in that answer. That is my solution, and that is all I have for today, folks. So the McCully fun fact of the day: Mr. McCully loves bad 80s movies, and you should watch them. So after you've done your review Blizzard Bag worksheet today, I highly suggest a choice of one of these 3. I think that they're all on a streaming service somewhere, either The Adventures of Buckaroo Banzai, Big Trouble in Little China, or the original 80s Flash Gordon. You won't be disappointed. Have a good day, folks. Goodbye.